Hi everyone, my name is Doris Lee, and today I'll be talking to you about the latest feature that we just introduced, which is Pandas on Snowflake. And so to get started, many of you have probably heard of Pandas if you've ever kind of worked with Python, work with like data science tooling, you'll know that Pandas is a super popular data science library that's used for data analysis, data cleaning, transformation, and so on. And the reason why Pandas is so awesome is because it's super flexible, it's very expressive. It makes it very easy for people to do prototyping and experimentation with your data. It's also super widely adopted by the community and data practitioners at large. It has something close to like 5 billion downloads and also is used by 1 in every 5 developers. Now, we all know that, Pandas is a super popular tool, but one of the challenges that we see a lot in industry is that Pandas doesn't really scale. And by that, we mean that when you're looking at large data sets, when you're working with big data, Pandas doesn't really work well in those use cases. And so I wanted to, take a look at why that is the case. And in order to understand why, you kind of have to kind of peel behind kind of what Pandas actually does. And so as a developer, you kind of just use Pandas, right? You never really think about how it works underneath the hood. But what Pandas is actually doing when you're working with your data is that Pandas is an in-memory data structure. So all the data that you're working with needs to fit in memory. It's also single-threaded, so it means that all of the processing kind of leverages one of the CPUs that you have. And so this means that when we start to talk about enterprise scale data, that picture starts to break down, right? So Pandas requires that everything fits into memory. And so the moment that you exceed that limit, it leads to this very disruptive out of memory errors. Your notebook will start crashing, your application doesn't work. And then the other thing is that, again, Pandas is single-threaded. So when you're working with lots and lots of data, millions of rows and so on, you start to get the slowdown because there's no distributed processing. So even if you have, let's say, 4 cores in your machine, you can see here that, a lot of that is wasted compute because your computer is not able to fully utilize the resources that is available because, again, Pandas is single-threaded. And so what that means is that, Pandas really doesn't scale well, especially when you get to this regime where you're working with tens of gigabytes or millions of rows. It depends on the size of your machine, but generally, when we're starting to get to that medium to large data set regime, we see that Pandas starts to slow down and then ultimately, runs out of memory. And so what does this mean for like organizations, right? Organizations that use Pandas and build out their pipelines and workflows. So when we actually go to talk to a lot of the data teams that uses Pandas, what we actually find is that the prototyping to production phase can actually take anywhere from like several months to even like 6+ months. When you're taking a Pandas workflow, let's say a notebook that you're working with to production when you're working on your enterprise scale data. And here's why that's the case, right? When you look at these organizations, we're often using Pandas for this initial prototyping and data exploration phase as new business requirements come in, new data come in. And again, data teams love this because of all the reasons that we talked about earlier. It's easy to prototype, it's easy to iterate and work on your data, visually kind of see what's going on here. And so most of this prototyping work happens either on a single laptop or a single shared workstation where the data team can very quickly sort of test and experiment with their data in an agile way. However, the trouble is that the moment you need to look at more data, maybe this is when you're testing or productionizing on a larger sample of the data, this picture starts to break down. So as we saw earlier, like this Pandas, which is the tool that you're using for the prototyping phase, doesn't scale to this phase. And then this is true even as you work on more and more data as you put things in production. And so to work around this limitation of pandas, data teams are then forced to rewrite their pandas workflows into a different sort of big data frameworks. And that could be Snowpark, SQL, Spark, whatever the data team needs to do to operate on more data. In order to move these workloads to the cloud to run on larger data sets. And so when we go from this prototyping to production cycle, you can now see why it takes more than 6 months to productionize these workflows. It becomes very time consuming to have to constantly rewrite these workflows into these more scalable frameworks. So as an example, one of the organizations that we were working with is a very large mature data organization. They have told us that it took more than 6 months just to take one of their Pandas workloads and rewrite it into Spark code so that they can operate on more data in production. And so this is an incredibly frustrating process for developers. This could be time spent putting more models or more pipelines in production. Um, and so the other aspect of this story is that like the story doesn't end here, right? So we know that working with data requires a lot of iterative processing. It requires that you go back and make tweaks or changes to your pipelines or models when new data comes in, when you have bugs that are introduced or models need to be changed or so on. And so this rewriting process is not really just a one-time process. It's not just, hey, I do the translation and I'm done. It's a constant overhead that makes it difficult for your team to maintain and debug your data pipelines and workflows in a very agile way. And so this can lead to very frustrating development and feedback cycles. And so, what I hope you take away from this is that all of these points of friction of having to rewrite our code just to be able to tune up this knob of being able to work with more data starts to add up, right, in terms of the human time and development cost. And it becomes a very real challenge. And so, to address this issue, we've spent over the last 5 years developing this open source project called Modin. And Modin is essentially a scalable, more distributed version of Pandas. And the way that Modin works is that it's a drop-in replacement, meaning that all you need to do is change one single line of import, and you can now work on much larger data sets with better performance. And you can also continue using your familiar sort of Pandas API. So in the animation here, you can see, my read CSVs, my group bys, and with the Modin runtime, it's much faster since the operations are running in parallel. And Modin is an actively maintained open source project based off of some of the research that we did at Berkeley on adapting database and distributed computing techniques to Pandas. And the Modin open source project joined the Snowflake family last year to help us scale enterprise data workloads through open standards. And we've been, from then on, we've been working to bring this first-class Pandas experience to the Snowflake Data Cloud. And so, as part of this, we recently introduced the general availability of Pandas on Snowflake. Pandas on Snowflake allows you to run your Pandas code directly in Snowflake by pushing down the compute to the underlying Snowflake engine. And so with this capability, you now get the same Pandas native experience that you know and love, and also kind of the security and scalability benefits that you get with the Snowflake platform. We've run some benchmark comparisons on representative workloads that shows that Pandas on Snowflake can scale up to a terabyte of data. And in fact, if you look at the bar on the fourth bar on the very right, you'll actually see that it only takes less than 50 seconds to run on a terabyte of data. And in comparison, if you look at the gray bar, which is what you would see with the performance of vanilla pandas or regular pandas, which is single-threaded and in memory, you'll see that Pandas runs fine when you're at the 1 GB to 10 GB range. It's a little bit slower when you look at the 10 gigabyte range, you'll see that it's, the pandas on Snowflake is running 30x faster than regular pandas. But then when the moment you start getting to that 100 gigabyte to like 1 terabyte range, like Pandas completely just runs out of memory. And so this is where Pandas on Snowflake really shines, where we see significant scalability and performance improvements. As a glimpse to how we're doing this underneath the hood, here you can see that the user is writing some data frame queries. So pd.concat combines two data frames horizontally. And then what we do is we take this query and we translate and push this down to SQL so that this is running on the Snowflake engine. And this is based on a lot of the work and learning that came from building the Modin open source project. In fact, our Pandas on Snowflake offering is really built on top of our Modin open source library and really integrated with these open source standards. And so with that, I wanted to show you a quick demo of how you can leverage Pandas on Snowflake to analyze large amounts of data. So what we'll be seeing here today is an example of how you can use Pandas on Snowflake running on Snowflake Notebook. So you can see here that I'm logged into Snowsite and I have my Snowflake Notebook open. And in order to use Pandas on Snowflake, what you'll have to do is you have to go to your packages and then you'll install Modin as one of the additional packages. And then Pandas on Snowflake is delivered through Snowpark Python. And Snowpark is part of the built-in set of libraries that comes with your Snowflake notebook, so you don't have to additionally install that. So with that, I'm going to run my import, and you can see this is the 2 lines of import. I import the Modin plugin and then Modin itself. Note that I imported modin.pandas as PD, so that I don't have to really change my code from pandas to using this new library. Now, the other thing that I need to do is create a Snowpark session. And so that allows me to connect to my Snowflake session. And you can see that within my Snowflake notebook, this is relatively easy. All I have to do is call get active session, and I'm able to get this session object, which I can use Snowpark Pandas with. Now, I have this data set that I've loaded in terms of the from the Snowflake marketplace. So this is the CyberSyn finance data set, and in particular, this is a stock time series data set. So you can see that here, what I've done is I use pd.read Snowflake. I reference the table, which is the stock time series table. And then what that does is that it doesn't actually pull all the data into memory. What it does is it just establishes a connection to this table. And then now I have this handler, which is my Snowpark Pandas data frame. And this took about 8 seconds to run. And there's a total of around 70 million rows in this data set. Now, I wanted to show you, let me just run this because this takes a while to run. I wanted to show you if I was to do the same thing without Pandas on Snowflake, what would you actually do here? So there's 2 approaches that you can do. Both of them require pulling the data out of memory. One is you can use session.table from Snowpark to reference this as a Snowpark data frame. And then what you would do is you would do .toPandas to pull all the data from your Snowpark data frame into a native Pandas data frame. So that's one approach you can take. The other approach is if you are using the Snowflake connector for Python, you can execute a query. This is just a select star query on all the rows in this data set. And then you do fetch pandas all. And then the fetch pandas all fetches all the rows in this result set and loads them into a pandas data frame. And so you can see that this command is still running. It's been almost a bit over a minute now. And the reason why this is really slow is because it's pulling the data serially um, into this data frame, and so this is going to take a while. Okay, so you can see that this query has just completed. The query took about almost 3 minutes to run. It's 2 minutes and 43 seconds. And this is obviously much longer than the, I think, 9 seconds or so that we saw earlier. So again, this tells you that Pandas on Snowflake is much faster, even in terms of this initial loading of the data. Now, once we have our Snowpark Pandas data frame, we can start to do all your familiar pandas command on this data frame. So first we can do df.head, which allows me to kind of take a look at the first 5 rows of this data set. I can run my Streamlit command to visualize this data frame. I can also do filtering on this data. So I can do look at all the stocks in the New York Stock Exchange, and took about 2 seconds to run. Um, and then this is the resulting filtered data frame. Could also do sort of a filter of Google, Microsoft, and Snowflake stock, and then look at the pre-market open price for that. And if you're a Pandas user, you'll recognize that this syntax that I'm using here looks exactly the same as the filtering syntax that you would do if you were using Pandas. Now, the next thing I want to do is I want to pivot and reshape my data. So if you scroll back up, this is what my current data looks like. It's sort of this, I have these variables and then the value itself. Now, what the pivot table does is that it's saying, hey, I want to, have ticker and date as the index, but I want to extract all the values and arrange these based on the variables itself. So these values are going to be in the table itself. If you take a look at that, these are now the values, and then the columns itself is the variable name. So is it like an all-day high? Is it, post-market close, and so on. And again, we can visualize the first, the head, which is the first 5 rows of the data frame. We can also do data transformation. Again, this is a time series data set. So one of the things that is really useful here is I can do resampling on a quarterly window. In this case, the resample is quarterly. Quarterly is just a 91-day window. And then I want to take the all day low kind of column and extract the min of that. And so this is the resulting series from the quarterly lows. Now we can even do things like diffing. So I have this series object. I should actually do diffing across these to get the month to month, quarter to quarter fluctuation across each of the quarters. Finally, one of the things I wanted to show here is, Pandas has this functionality called apply, and apply is the way that you can input arbitrary user-defined Python functions across a particular axis or data frame of the data frame or series. And so in this case, let's say I want to apply the absolute value square root of every single thing in this series. And so the way I can do that is I can use NumPy, and then this is my Python function where it basically says I'm going to take the absolute value and then square root of every single value. And then what this actually does is that this Python function is converted into UDF or UDTF, and then pushed down to Snowflake, so that the function is running in our Python runtime. And let's take a look at the result here. I'm just going to drop one of the null values and print out the resulting series. And so the resulting series should be the absolute value square root of the prior series. So this is the resulting values. And note how even though this is all pushed down, I can actually use NumPy, which is a third-party library, within this UDF or this Python function. Now, finally, I want to take um, uh, the series that I had earlier, which is this one, and kind of just visualize the quarter-to-quarter fluctuation for the stock price. And so, in order to do that, what I can do is I'm gonna first do some data transformation to you know, reset my index and change the plotting data. Um, and then what I'm going to do is, in order to use third-party libraries with Snowpark Pandas, what you have to do is convert it into a Pandas data frame, because a lot of external libraries are not going to accept Snowpark Pandas data frame as an input argument. So what you do is you call this toPandas, which pulls the data out and then converts it into a Pandas data frame object. Note that the class signature after the conversion is different before and after the toPandas. And so now with the converted Pandas data frame, I can then use a plotting library such as Altair. You could use Matplotlib, whatever is your favorite plotting library, and take a look at the quarter-to-quarter fluctuation. So I have all the negative ones in yellow and then all the positive ones in blue. Awesome. So that concludes our demo. Just to recap, in the demo, we saw how you can very easily sort of work with your existing Pandas API to analyze a stock time series dataset. We were working with 70 million rows. All of that data was living in Snowflake. We didn't have to pull the data out or do anything until the step where we were visualizing the data. And so with Pandas on Snowflake, you can keep your data in Snowflake from prototype to production. It doesn't matter if you're working with, several megabytes of data all the way to sort of like gigabytes or even like terabytes of data in production. You don't need to rewrite your code from Pandas to another framework just to be able to scale up to larger data sets. And so this is really around being able to keep that same API and minimize the data movement that is required. And so to recap, these are some of the key benefits for using Pandas on Snowflake. So we took a look at some of the reasons why Pandas doesn't work very well on large data sets earlier in our talk today. And we saw how Pandas on Snowflake enables developers to continue to use and work with their data by writing Pandas code, and how we can automatically compile your Pandas code to run on the Snowflake end by pushing down the compute to Snowflake so that you get the benefits of distributed Pandas at scale. Second, there's no more sort of out of memory issues that you'll run into or security concerns from pulling data out of Snowflake because you can now work with your data Pandas code at scale. Developers can leverage their familiar Pandas API, which then frees them up to optimize for business outcomes and putting more pipelines in production. And so finally, if you're interested in trying out Pandas on Snowflake on your own, it's really easy to get started. All you have to do, if you already have a Python environment set up on your laptop, your local machine, all you have to do is do a pip install. The command is here, and then do a two-line import to get started. If you can also try using it in a Snowflake notebook, and we saw an example of how that worked in our demo earlier. So make sure to also check out our quick starts and documentation for more examples on how you can get started with Pandas on Snowflake. Thank you all for joining the session today. I'm super excited to see what you can do with Pandas on Snowflake.